No, that's all good.
Okay, next presentation is PROCONICS, Drone Technology and Engineering. This is Robert Theron. He gave me a whole bio and I left it at home. So I'm going to be really rude and ask him to please introduce himself. It's not the done thing, it's not the norm. But please bear with us. Robert, thank you very much. We really appreciate it. And once he's finished, he'll be downstairs as well, and you're welcome to carry on the conversation further.
Good morning, everyone. Hi, my name is Robert. I've been with PROCONICS for 13 years. I brought PSC with me to help me today. PSC is the responsible person flight operations at PROCONICS. I'm a little bit of jack of all trades, but I'm the head of ICT, automation, and then the unmanned aerial systems that you see here behind me. So I'm not very good at presenting, so the way that I convince myself that this will all be fine is to say that this is not a presentation, this is just an informal discussion. So I invite everyone to please ask questions while we go along. You don't have to wait until the end, just stick your hand up and ask questions. And the idea around this is just to show you how we leverage and use 3D technology to help with engineering at PROCONICS, and the idea is to sort of share what our experience has been around it. So there's going to be a lot of switching between my laptop and PSC's laptop. So now I'm not saying that Apple is better, but I mean, we'll try and take it from there. So on paper, I'm an electrical engineer. By trade, I did control and instrumentation. But the presentation today, you'll see there's a lot of benefits for all of the different disciplines. I mean, some of the biggest ones you'll see is for the plumbers, piping engineers, sorry. And the Lego builders, civil engineers, sorry, I just keep messing them up. But it's great to see the SAIMC here today as well. We had the privilege of having a presentation for them yesterday in Johannesburg. So thank you very much for coming. All right, so let's jump right into it. Does anybody recognize the plant they see in front of them there? Nobody? Oh, I'm safe. Okay. No, it's not RIF. So firstly, why would you want to use a drone in engineering? And there's three very big points that we found to be relevant to this, and it's you're bringing the plant to the engineer. So imagine when you're doing a site walk and you're walking through the plant and you have an entire team of people with you. So you have your civil engineers, your piping engineers, mechanical engineers, electrical engineers, and you have a massive team, and this is a really hazardous area. So we found the drone to be a great tool for this, and I want to sort of tell you a story of how this started. We did a site walk for Transnet many years ago, and we had this brilliant idea of mounting a 360-degree camera to a hard hat. So you can imagine how ridiculous we looked when we pitched up there. So we had these 360 cameras on our hard hats, a little blinking light, and we were walking around there, and the representative from Transnet was like, okay, this is the first. And this is sort of where we started, to capture these images while we're doing the site walk. We take this back to the team. We're able then to discuss it with the rest of the team, and we have a digital record of what is happening in the plant. And this is that was the first thing that sparked this whole journey that we then went on, where we are eventually now today. The second big thing is record keeping and progress monitoring, and this is sort of the first thing that I'm going to start handing over to Piers here, and you can unplug so long. And then the last thing is the age-old saying of measure twice and cut once. So by having a very accurate digital twin right on your computer in your office, you sort of eliminate the repeat having to go to the plant, having to check again, and then obviously it's a digital record. So when you complete a project, you have the as-built of what it was before that, and then you have the digital twin of what it is afterwards. So, Peter, if you want to talk through this.
Sure. All right. So this is a project we're busy with in the R. It's about a 10-hour drive from here. It's not easy keeping your eye on the project the whole time, and especially because you do invoice payments based on progress. How do you know what is a true reflection of what you're getting? So in the background there, you'll see that's just your normal Google Earth type image. And then you have the plot plan overlaid on it for this specific site. So what's really nice about it is that, so we flew it on the 5th, in May, and then just after that again on June. So there were certain requirements that the subcontractor had to fulfill in order for them to get their invoices paid. And part of it is they had to put a gravel out, and some of the equipment had to be delivered. And now you can exactly see what has transpired in those 30 days. And you can also see that they stuck to the actual plot plan as was agreed upon. So this is very useful, especially in large projects where you have multiple contractors that you need to manage at once to make sure that everyone's actually sticking to the plan. No one can tell you, no, we've actually dug that trench and you get there, but you haven't. Or you just started, but where's the rest of it? Okay, so just to show you also, the internet helps. Okay, so that was, the road had to be widened, and then also talking about trenches, 4 cables to boreholes. There you can see there on the right-hand side, there at the bottom, there on my cursor there. So there you can see they actually started with the progress on that.
Yeah, thank you very much, Betsy. So, I mean, you can immediately see the benefit that you have by using the drones to do progress reporting on a project. And the whole, the way that this presentation is set up is to sort of take you through a journey. So this is sort of where you can start off with drones, flat 2D maps. You take regular images, you stitch them together, and you start building a portfolio or a record of your project. So we recently completed the Mayuba ash handling plant for Eskom, and we were able throughout the entire plant to build a record like this. In our weekly or bi-weekly progress meetings, you just move the slider and you can see the progress immediately, and it's a good way to show what is actually happening in the plant without people having to go and look. So, situations that you never want to get into, like litigation, this is also a very powerful tool because these are all date stamped and geo-referenced photos and maps. So, very powerful tool. Yeah. All right. So, as you look through the evolution of how this, LiDAR scanning and modeling has gone through the ages, we're all aware of LiDAR scanning. I mean, that has been around for very long, the traditional terrestrial type LiDAR scanning. And, most of you have seen this. It's where you have a LiDAR scanner at a fixed location in the plant, shoots out billions of points. You come back with a sort of a granular point cloud, and you're able to do your engineering within this point cloud. Now, even though this is not, it's a pretty old technology, it's super powerful and it's still being used all over the industry. But what's exciting about this is where they're heading with it. So the next very big iteration of this technology was to combine it with SLAM. So simultaneous localization and mapping. So this is where the LiDAR scanner doesn't need to be in a fixed position anymore. You can move it around while it's scanning. So some of you might have, been, exposed to this type of technology. And a lot of the new terrestrial scanners does this method of SLAM, whereby you scan, you're able to move it, and it does the registration on the scanner itself. So it decreases a lot of time. So it was an eventuality that this type of technology would move to portable equipment like, for example, drones. And wearable technology. So we're going to show you an example now of a substation that was done using a SLAM-based scanner by wearing wearable tech, and the person was able to walk through the substation. So you'll see there a little picture. Yes, you can swap over. So what's great about this is the massive time saving that you get by taking a digital twin. So remember where this started with a little helmet and a 3D camera? So now we've replaced the 3D camera with a LiDAR scanner, and you're able in real time to map the area that you walk through.
Okay, so this was a rather large substation we needed to do, and we had to inspect the buckets on the inside. So our engineers had to go and take thermal images of it. And now someone obviously needs to do the work. And especially if you don't know the actual plant, or the substation, it's pretty tough to navigate your way around. So you can get 3D models like this, but we've also realized a lot of times the need is not to have this highly accurate point cloud model. It's just to have like a Google Street View type environment where I can navigate and make annotations. And this works pretty much in the same fashion. So you just double click on your model and you're on the inside, and you can walk around in your entire substation from there. And the detail on these photos are actually pretty insane if you look at how far you can zoom in on them. You know, but now here's the really cool part. Let me just take one step back. So there you can see there's a little report, and there it opens up. And now your client can respond on that annotation and say, okay, here's the project number or your JCE, you can go ahead and you can do the actual job on it. And we also found that it's pretty useful because it still has the measurement and 3D environment in it. You can go and do your measurements on it. So if you have to look at the size of buckets, or another very useful use case we had for it is you had to get the buckets into the substation, but nobody thought about the size of the door. All right, so now you have the 3D model, you can measure the door on the entrance, and you realize, oh shucks, we're going to have to make the door space wider to get the instrumentation inside.
Yeah, thank you. So I hope everyone can see the common theme here. So again, this is another good example of where you can take the 3D or the digital twin of the substation. You're able to take it back to the office, sit around the table with your team, and you can do design planning and engineering from the safety of the office. You don't need to expose people to a substation. And I mean, the electrical engineers would know a substation is actually a very dangerous place to be. So the next, natural progression would then be towards 3D modeling and mapping. So once you have the ability to capture these images through photogrammetry and through laser scanning, you obviously want to create a 3D model of what you are working with. But the 3D model obviously needs to be of such quality that you're able to do engineering on it. So this was a big challenge for drones. This is sort of where the drones did not do well. It does well at taking beautiful videos, beautiful pictures. It builds these amazing environments, but they're not accurate. So again, the plumbers, piping engineers would know that if you say your accuracy is around 20 to 50 millimeters, they would laugh at you. They want 1 to 3 millimeter accuracy when they do tie-ins, for example. And this is sort of the Achilles heel of the drone. But this is something that we've been able to work around and to solve in certain, aspects around the processing, and then also the natural evolution of the cameras and the LiDARs. You can see from where drones typically started with the ones you buy at the China Mall, to the one you see in front here, that's about 750,000 Rand to start. So they get quite expensive very, very quickly. So on the screen there, you can see some 3D models that we've taken. Again, on the left, it's a gasification facility of a very big petrochemical provider very near to us. And imagine you would have to scan that piece of plant that you see there with a terrestrial scanner. You're thinking months, right? It will literally take months. And a lot of what you see there is detail that would actually not be possible to capture at all. The drone can obviously not get into those spaces, and that's why there's always a place for terrestrial scanning. But imagine now having been able to join the terrestrial scanning that you've done and the drone scan on the outer, and then having this completed 3D model. So to give you an example, this specific scan was taken within a day, and the processing took about 4 days. This, with terrestrial scanning, would have taken at least 6 to 7 months of daily scanning. So the time savings are real. So Percy will show you another example now of a 3D model. Again, apologies for the back and forth, but Apple, it's a little slow.
All right. Okay, so this was a very complex environment to map, and was actually a challenge given to us by our client to say this is like having spaghetti. So there you go and try and map. And we accepted the challenge, and our very capable pilot there at the back, Mpo, was part of the project and came back with some really good results. And this is all with photogrammetry. So just the internet might lag a little bit, but let me show you the detail on this.
So this is an actual 3D model. It's
Yeah.
It's not a map. It's not a flat map. You'll see now it starts turning
Yeah.
around as well.
I mean, on the high-end model, you can even read the embossing on it. So that's the kind of quality you're getting. And on this model, you can now do your measurements, you can share your annotations, and the whole team have the plant right in front of them to do whatever planning they need to do. So also where we find this very useful is in the beginning of a project, determining laydown areas, creating the plan for the cranes to come in and go out, making sure the containers of each subcontractor is clearly marked. So very, very useful tool once again for project management. So we use this a lot in our own team. And this is where the main value comes in for us, is saving our time and making sure we minimize on rework.
Yeah, so again, I don't know how many of you guys have ever been involved with engineering models and point clouds, but if you zoom out again, just look at the sheer size of this 3D model. It's massive, and you're able to zoom in and you read the tag numbers on the valves. I mean, that's how far this technology has come. So, I mean, it gets me really excited. All right, if you can plug that. Okay, so I'm going to show you two other use cases now of where we use 3D. Where we use 3D models. This was, we were approached by a scaffolding company from Germany, and they told us that during the shutdown they need to do, a bit of a design on this vessel. So our Mechchem friends and partners will recognize this as well. Mechchem did the 3D model on the left-hand side. We flew the images for the drones. And then the scaffolding company called Layer, they did the scaffolding design using their scaffolding software, and then they were able, on the right-hand side, you see the finished product. So this is a showcase of how drones helped a scaffolding company, which is actually counterintuitive because scaffolding companies don't like drones, to design and build scaffolding in such a manner that they achieved a record in which they were able to build the scaffolding at Sasol. So a very good use case for drone technology. And then again, for inspections, this is sort of a showcase product for us around the cooling towers. It's actually impossible to 3D model a cooling tower using a drone due to the manner in which the cooling tower vibrates in operation. So I don't know if you've seen these videos where they have a glass in front of a speaker, the glass begins flexing, and then eventually the glass breaks. So a cooling tower does exactly this. The beak of the cooling tower keeps flexing open and shut very quickly, and then once you try and do a model of the cooling tower, it's extremely blurred and very inaccurate. So we found a way using the drones and in the method that we do the photogrammetry processing to create a very accurate 3D model of the cooling tower. And the reason for this was we were requested to come have a look because there's pieces of concrete falling out of the cooling tower, and they wanted to identify how big these pieces are and where they are so that they're able to plan for the shutdown and then obviously start planning for the repairs of the cooling tower. So PSA, if you're ready, then again we can quickly just show you the cooling tower. Okay, so here you can see the 3D model of the cooling tower, and as PSA rotates around, the great thing about this is you can not only measure the actual damage to the cooling tower, but this is a digital record of what the situation was at that specific point in time, and then also the localization of it. So because these photos and these models are located within the XYZ axis, they knew exactly where the damage on the cooling towers were beforehand. They could assess what the damage looks like, how big the damage was, and what needed to be done to have it repaired. So this model was sent to the refractory company, and they were able then to very accurately plan what needed to be done during the shutdown. So the massive cost saving in getting this cooling tower repaired. Yeah. And then just a quick other thing I want to show you is around the smokestack. So again, this is another great example of something that isn't humanly possible to do. The smokestack is just over 300 meters up into the air. You have to, if you do an inspection while the smokestack is running, you have to have a BU set with you. It's a very dangerous environment, and we were able to do this inspection with excellent detail without exposing anybody to harm. The pilot was safely on the ground, and we were able to do this while the smokestack was running. So this is an environment or an inspection that would not have traditionally have been possible to do at all. Okay, so the next logical iteration from there would be, how do you interact better with these 3D models that you've now generated? So, the next logical step would be to transfer these models into virtual reality. Now, this is not something I can demo to you. It's something you have to personally experience. So if any of you ever want to experience this, you're welcome to come make a turn by us and we'll show you. But you've all seen VR before, and you're able to walk around within these plant environments that you've now captured. So if you've taken a 3D model of the plant area that you've designed in, and let's say you've designed a walkway over a platform, you can physically walk through these environments and look at ergonomics, like can you still get to the valve, can you operate the JB? So very great, very, very good for those circumstances. And then also what works really well is for training. So imagine you have a virtual reality environment and you're training someone how to do road loading safely, for example, or to operate an operator station of a plant, but in virtual reality. So again, sticking to the theme of removing people from the actual hazardous areas, but still giving them these immersive experiences. So one of the use cases for this actually, and it's not now engineering-wise, but it's to test if people are afraid of heights. So many people say they're not afraid of heights, but then the moment you expose them to real dangerous environments and working at heights, they freeze up, and this is a very dangerous position to be in. So I'm excited to see some of the training facilities starting to use this type of technologies to see whether people are really afraid of heights, and then obviously give them the training they need to do it safely. So then there's one last thing after the virtual reality, and that is augmented reality. So the problem with virtual reality is you can't walk around in the plant with these goggles over your eyes because you're not going to see where you're going, right? So a dangerous situation. So think about if you're a contractor and you need to replace a piece of pipeline during the shutdown, but the problem is you get to the plant and now you're not sure, is this the pipe I'm supposed to be cutting? This is something that plays out often. So very dangerous situation. It could be a charged pipe. There could be flammable materials within it. And if you had the ability to, through your safety glasses, look at these lines, and you have something like shown there that shows you this is the line you need to cut. Now, you'd eliminate a lot of injuries. Now, this technology sounds a little bit far-fetched, but we're there. So our CEO has a saying. He says that the future is here. It's just not equally distributed yet. So you already get EX-rated augmented reality glasses. So I don't think it's far from here where we'll be able to walk through the plant and you'll be able to see pressures and temperatures and flows of lines and of tanks. That's in real time, and you see it through your glasses. So we recently did a bit of a feasibility study with a client of ours, and we're hoping that the project goes ahead. But this is exactly what they want to do. So they want to be able to identify pumps and valves, and if you look at a pump, it should show you what is the originating tank and what is the from where to where the line goes. So very powerful technology, and then. The last slide is just to show you, I'm trying to go quick. The last slide is just to show you a little example of augmented reality. Now, this is of the L Road Plaza in Johannesburg, and I do have permission to use this. It's Sasol's road loading station. And the intention of this model was for marketing initially. They wanted to use it as a nice thing. But they found a lot of value within it for training. So they actively use this model at the moment at L Road to train new people who join there and train Sasol people and how the operations look and how it works within our Road Plaza, again, without actually exposing people to the area itself. So I'm just going to play this video, and I'm hoping it works like it should. So this is in my office, and this is done from my phone. So you can see there it was a plot plan that was lying on the table there. And by looking at it through this app, you can see the 3D model of the plant popping out of the plot plan. So you see there's little blue dots in between the tanks. Those are points of interest. I'm going to click on one of them now. And then you're looking at the area from the viewpoint of the drone. So this is me actually moving my phone back and forth. And as I turn with my phone, the video, turns on the phone because it's the stationary position that the drone was in at that moment. How cool is that? All right. And yes. Yes, ma'am. Yes, do you want the mic?
Should I stand on it?
As you wish.
Hi, my name is Sipisihle Gubega. I am the founder of Aerotech Drones, and pretty much all the business cases or use cases for drones is something that I am intending to go into. So it was established in November, and since then I've been spending my time in compliance. Yeah.
That's a big headache.
So I think I'm about a few weeks away from being ready to work. So what's the situation with PROCONICS and subcontractors, collaboration, joint ventures, those type of things? And then also, what's the opportunities there? And then whether in the value chain you guys just do everything yourselves or do you outsource some of the things?
I'd like to answer that one, Pierce, if you don't mind. Yeah. Okay, so I don't know if many of you know, but running a drone department is like running an aircraft company. It's an airline. So you'll see drone pilots have licenses from the Civil Aviation Authority. We log our flight plans like you would do with an airplane. I don't know if you guys noticed, but there's stickers around the drone that says ZT-WYD. And I don't know if you've noticed at OR Tambo that all the aircraft at OR Tambo start with ZT- and a number. So this is an aircraft, a registered aircraft, according to the Civil Aviation Authority. I'm allowed to touch this drone because I'm certified and I have training. But if any one of you were to touch this drone, we would have to report it to the Civil Aviation Authority as a breach of security. Yeah, that's how strict they are. So we need special permission to fly over Sasol. Obviously, it's a national key point, and Sasol is strict about it. But even if we were just outside of this door and we would take off this drone, and there's no registered flight plan, no flexible use of airspace, no permission letter from the CAA, we could be grounded and fined massively. So to fly these, and that's important, if you choose an operator for drones, choose someone who's, number one, legally registered with the CAA to be able to do this. But number two is choose a responsible operator. So we always have this saying, it's very easy to fly a drone. They fly themselves, basically. But drones fly on paperwork. So we have an internal rule in PROCONICS is we don't take off with this drone in Sasol if we didn't look at the area classifications first. Make sure that the areas you fly in, if there's zone classified, you have to have a hot work permit, stay out of the zoned areas. If you need to go into a zoned area with a drone, do it under hot work conditions. And then also, we didn't bring it with us, but this drone has a special bracket in front here that has a gas detector mounted in front of it. It's something we designed. It doesn't come with the drone. And this stop camera looks at that gas detector. We have an additional safety officer with us. If that gas detector detects gas, we have an emergency plan where we fly out of that area as quickly as we can. So, be careful when selecting drone operators and make sure they know what they're doing. And if they tell you my drone is waterproof, it's fine. It's not fine. Waterproof does not equal EX or IS rated. That's the one thing. And then the other thing is there is a company developing EX drones now. The problem is you're flying at 100 or 125 meters up into the air. If that drone crashes from that height, it's no longer going to be EX rated. So always assume that there's a big risk. Yes, ma'am.
I'm Sohana from More Process Controls. Just taking it back a notch, we have a client that wants a camera and they want to monitor a conveyor, but they also want reporting on rock size on the conveyor. Is that something you guys can do?
Yes. No, definitely. So we do condition monitoring on some conveyors where we fly with like thermal cameras. So we fly up and down the conveyor very quickly, and then we feed this into an AI software that tells us which rollers need to be replaced, for example. So, I mean, it's very easy to train this AI program that because of the way that drone cameras work and how that processing work, you'll be able to determine the size of it, and you can feed this into an AI program. You teach it, the size of rock, and let's say you have a limit. If it sees a rock above a certain size, it'll stop the conveyor. It's simple to do. So yes, definitely possible. Yeah, definitely possible. Ma'am, the one that asked about the compliance stuff, I'll have a chat with you afterwards. Okay, sorry, I don't think I answered your question.
You mentioned that at the beginning of your presentation, you mentioned about the record keeping and progress monitoring.
Yes.
So I'm the founder of I Do Construction, Mr. Manko and ESCOM. So my guys working, sometimes they're not working. So do you also do that? Do I need to put something, a drone or? I'm just, my background is mechanical engineering and project management. I was with you guys in Sasolberg with Takarani, I think, yes. So I just want to know how do I, in terms of progress and progress monitoring and all that.
Yeah, I mean, obviously, it's almost like having a CCTV camera behind someone working on their laptop. So people don't like it, but I mean, we have done it before. So I'll give a really good example where something like that was useful using drones, and that was around crane operations. So there is a rule: you're not allowed to take video footage while the crane is actually picking up the equipment. But I mean, you take the video footage while the crane is moving into position. So I'll give a good example. This did not happen in South Africa. It happened in Saudi Arabia, where a very, very big crane operator was moving their crane into position, but it was a very small pathway where this crane had to move through. And kudos to the driver. It took real skill for that crane to stop there. But what happened is the plant then accused the crane operator of damaging a piece of the plant, and the fine was $5 million. But because that drone operator used the crane operators used drones to video film this entire operation, they could go back to that video and they could show that that piece of plant was damaged before the crane even moved through that area. So that just gives you an example of how progress monitoring can be done using the drones. And I mean, I'm sure you can do it in a similar manner with your specific use case. Right, is there anybody else with it? Is that it? All right. Thank you very much, everyone. I appreciate the attention. Thanks.